get started. So just wanted to talk today a little bit and share my experiences with using the Solidus Events system when extending Solidus and how it has helped separate concerns in my applications. First of all, thanks for the great intro. A few more words about myself. Most of you probably don't know me unless you've worked with me before or currently work with me at Supergood. You can find me on most social platforms as Forkta, including GitHub. As Thomas mentioned, I've been working with Ruby and Rails for a while now, since 2014. Previous to that, I was a .NET developer, but since switching to Ruby and Rails, I've never looked back. I've had the opportunity to work on Spree and Solidus stores for a long time, so it's really a great honor to be here and able to share some of the things that I've learned throughout the years with you. The first store that I worked on was a Spree 0.3, I think. And this was back in the days when I worked for StemVault or Free Running Technologies at the time. As Thomas mentioned, I'm based out of Victoria, BC, where I live with my wife and our two dogs, Baxter and Misha. We do enjoy the outdoors as we have a lot of beautiful places to explore out here. But today I'm here to talk to you about separation of concerns and how we can achieve that when we extend Solidus. I'll go over why I think it's important to keep that in mind when we build Solidus stores and give you a brief overview of the Solidus event system. Mark, who's speaking tomorrow, is going to dive much more in depth into what's coming in the next version of Solidus, as well as the awesome work him and the rest of the team have been doing on improving. But today we'll get a sneak preview of that. And then I'll try to outline how this can help us improve when we build Solidus stores. So what do we mean when we talk about separation of concerns? Well, it is a form of abstraction that allows us to build software by breaking it up into distinct sections. This way, we can build more modularly and encapsulate or hide information behind interfaces in different parts of our code. This way, we create a layered system that addresses the separation of concerns. And you can see this really well demonstrated in Rails as a framework. There's a very distinct persistence or data access layer, active record. We have a presentation layer and a less well-defined business layer, but still there. One of the things that we gain by building on this is improved maintainability, and in turn, in some cases, easier framework upgrades in the context of Solidus. It also improves our code reuse. You can solve problems in many different ways, but there are ways that make it easier for us to change the code that we write and also reuse it. And lastly, but still very important, it helps us think about different aspects of our systems in isolation without having to keep all of the information in our head. The goal is that we want to be able to build, understand, design complex systems that function in ways that are independent in their components as well. So, of course, nothing comes for free, and there's some drawbacks or considerations when we build systems in this way. It means that we're going to be adding additional code interfaces, and as a result, we also need to make sure that different sections of our systems integrate and work correctly. There is also a small penalty in execution, but that is something that, for the purposes of this talk, we're going to look over. So why is this important or relevant when we talk about extending Solidus? We have already some very well-established patterns, and Jared alluded to some of these in his earlier talk today. Firstly, Solidus provides class extension points that allow us to replace entire classes or modules that the framework defines. Those are always the best way to go about it, as they provide a very stable and well-defined interface. Sometimes, though, there are things that we need to do to extend Solidus, and there aren't already defined extension points. Or maybe the framework is designed in such a way where it's hard for us to go ahead and do that. We lean into Ruby's abilities to monkey patch classes or modules that are defined elsewhere. And we're familiar probably with class eval, or more recently, we've been trying to use module prepend for extending certain behaviors or classes that Solidus defines for us. But today, I think I want to talk mostly about how we can use the event system to also extend Solidus. The reason why we want to sort of emphasize the importance of separation of concerns is because, in my experience, it's really hard to maintain override and custom code in storefronts. Oftentimes, I found that those overrides become kind of a dumping ground for various concerns that are not related to the responsibilities of Solidus, but they just end up in that place because it is the point where we extend Solidus. Oftentimes, that leads to custom business logic getting mixed with Solidus concerns. This is not to say that there is no room for custom business logic in override code, but I think it's good to aim for us to reduce that whenever possible. And if we are in a situation where we do need to introduce it, we can hide that behind a well-defined interface. This is a completely made up example here of a way that we can extend the order model from Solidus, but something that you might see in a lot of stores. We need some custom behavior to be executed when an order transitions to complete. And whether that is to send the order to external systems or perform other tasks like fraud checking analysis, oftentimes we find ourselves writing a lot of that code in our decorator classes. And depending on how we've designed that, we may get a lot of responsibilities of external systems leaking into our order models. And I think there's a better way we could approach this. So if there's anything that you take out from this talk today, I think it is that when we're overriding core functionality, we really want to do that when we're replacing existing behavior that Solidus provides that doesn't work for our custom needs. If we just need to add extra functionality or side effects, all we need is an extension point and a well-defined interface. Some examples that I've seen where a store may need to have some custom behavior is when some of the stock Solidus models transition to particular state changes. Previous example we saw is an order being completed, but that can be on shipment, on a payment. Sometimes external system need to be notified when stock changes in Solidus or changes happen to any other records in the database. Or if we're extending the store based on user actions. Analytics is a great example where the Solidus event system is a good fit. So taking a step back a little bit, if you haven't had a chance to work with the event system before, it is an implementation of the publish and subscribe pattern. This is a messaging pattern where senders of messages, called publishers, don't necessarily program the messages directly to specific receivers, called subscribers. Rather, they categorize the messages in classes. And in turn, subscribers don't necessarily care for who or if anyone is publishing. They just care the class of message that they want to consume and be notified about. The existing system currently in the stable version of Solidus is built on top of active support notifications, which is a library provided by Rails. And it is synchronous by default. But there is the opportunity to replace the in-memory queue that it uses as a backend with something of your choosing. The new version of this system, which is in master and you can opt in using, is built on a custom implemented event bus. And I won't go too much into that because I know that is probably going to be something that Mark discusses in his talk. But it does improve significantly in a few ways on the current implementation. So building on the event system, I think we get two really significant benefits. One is we can design our systems in a way that decouples individual components. That is great because it allows us to replace parts of our system without having to make major refactors. When individual components are designed in such a way that they don't know necessarily of their each individual inner workings, it makes it easier for us to change them. It also helps us with the problem I illustrated earlier with keeping related code close to each other. In my made-up example of the order decorator, we saw a lot of different concerns being mixed in the order decorator. And by leveraging subscriber modules, we can try to keep those extension points more focused and use them as bridges to custom code that pertains to specific subsystems in our application. So Solidus out of the box provides a number of events. Some of the more useful ones are the order recalculated and the finalized events. As the name suggests, one will get fired anytime an order is updated in Solidus. The other one hopefully fires only once when the order is completed, whether through front-end checkout or admin or API. And there's a few more events around reimbursements and specifically the processing of reimbursements. These are mostly used currently within the core platform to trigger emails, but we can consume them in our applications in any way we like. And I want to give you a few examples. So writing a subscriber to Solidus Events is relatively simple. Solidus out of the box provides a module called Spree Event Subscriber, which you can include in custom code in your application. That gives you access to the event action method, which lets you define an action and an event name that you want to trigger that action on. In this particular case, we have a very simple custom action that listens for the order recalculated event and just outputs to standard out. But here you can imagine you can put whatever custom logic you need your store to perform when this event triggers. One thing to note, events have a payload that is just a hash with key value pairs, and the order recalculated event in this example passes in the order as in the order key, and it's a spree order. So we can read values from that record. And that is, in essence, the API of this event. Testing this is also really simple because it doesn't require us to construct full complicated representations of the order object in a very particular state. For the most part, we can fake it. We don't need to know where this event is fired in Solidus if we want to write a unit test for our subscriber. Adding custom events to Solidus is also really easy. Here I have an example about overriding the order contents module and replacing or enhancing the update cart with an event fire. This is not an event that exists in Solidus. I just made it up. And I didn't need to change the way update cart behaves. Thanks to module prepend, we can fall back to the original implementation and then just add some extra behavior. In this case, using the spree event fire, we define a new cart updated event, and then we pass in a payload. In this case, an order and the result of the operation, which is the return value of update cart. It's a Boolean flag, true or false. It's important when designing events to focus on what you want the API for your events to be and to keep that consistent throughout your application. You might find yourself firing the same event in multiple places. you should always try to keep the API the same. Going back to the principle of separation of concerns, we want to have a well-defined interface to any systems that may be consuming this event. Originally, when I wrote this example, I passed in the full params hash as well. But then I took a step back and I thought, well, that might change. And if we're programming our subscribers based on what is in our params hash, that would require that code to know a lot about the system that is passing down that. So I would encourage you to be thoughtful when you're designing the API and specifically the payload for events that you're coming up with in your own applications. Testing this is also relatively simple. In the current version that is in Solid Stable, we have to rely on some of the mocking capabilities that our spec provides. But this is greatly improved in the new event bus. Unfortunately, there are many things that could fire events in Solidus, and specifically, it's not obvious, but in my test, I build an order, and that in turn fires the order recalculated event a number of times, especially because we're adding line items here as well. So I have to use a pattern here called as null object, which essentially tells our spec mock to ignore any calls to this method other than the ones that match the parameters specified. This is not ideal, and there's a few different ways you can work around this and write this test, like creating the order ahead of time rather than lazy evaluating it. But again, this is really improved significantly in the new event bus, which allows us to only register certain event listeners and track only events that we care about for in our tests. So not going to go too much into that, but it is coming soon from what I've seen on GitHub. Subscribing to this custom event, again, is very similar to what we showed earlier. In this case, I'm not providing a different event action than the name of the event, so I don't need to explicitly specify the name. In this case, very similar to the previous example, we just want to subscribe to the cart updated event and print out something to the standard out. The tests for this look very similar to what we did before. We don't need to know where this event is fired if we're just writing a unit test for our subscriber class. We just fire the event from our test and then ensure that we are passing the same payload that that event will receive when this code runs, let's say, in the cart update, in the context of the cart updater. So there are some things to consider when using this system to extend Solidus. And in general, some of these apply to evented systems, not just to the Solidus implementation. One thing we want to avoid is to have both components that are both publishers and subscribers. If you find yourself wanting to fire an event from your subscriber class, I encourage you to take a step back and think if there is a better way to do that, whether you need to send a message to a different subsystem, calling it directly might be one option, or if the actions that you want to perform don't need to run in the same order, then maybe you can add a different subscriber to the same event and implement another custom action that does the behavior that you want. So avoid this kind of creating event chains, because that can create probably headaches for you once you start changing the system. And you would be losing a lot of the benefits of that this system provides in terms of separation. We mentioned earlier that by introducing more interfaces in components of our system, we reduce coupling, but also increase the chance of these components not working together. I just showed some unit tests in these examples, but it's really important to, when you're building features on top of events, to ensure that end-to-end your system works in the ways that you expect it to. It is easier in this kind of a system to make changes to, let's say, the payload of an event in one place without realizing what subscribers there may be to that event and how they are accessing the payload. So integration tests are a great way to ensure that our systems continue to work together. Isolating the features that we build with subscribers in separate subscriber classes is also something that I would encourage you to do. It's very easy for us to end up in a similar situation to that order decorator, where if we have a single subscriber class for the order completed event, or sorry, order finalized event, we now have a lot of responsibilities to communicate with different subsystems. It is not much better than just doing what we've always done. So try to keep that separation clear to take full advantage of this framework. And lastly, this is one that I learned the hard way, but be careful when you're firing events from state machine transitions. In general, when you're adding state machine transitions, you have to be careful because they run in a database transaction. And if you raise an error, you could end up rolling back that transaction. But the issue that I ran into was much more interesting than that. It was with asynchronously running tasks from an event action that performed before the database transaction was completed. So keep in mind that sometimes if you are offloading work to, let's say, Sidekick, it could be faster than it takes for the database to get that data. Similarly, if you're splitting your reads and writes, you can end up in a situation where your action handler, if it's asynchronous, doesn't have access to the data that you think it should have access to because that data hasn't propagated throughout all the read nodes. Lastly, as with all things, this is not a silver bullet. There are some scenarios where extending Solidus using the event system is great. Solidus in its own uses it for mailers, and I've had a lot of success building an analytics integration with Segment using this approach. Additionally, I feel external API integrations could be triggered based on events, and active support notifications is used in Rails for monitoring and for logging. Of course, that's a good use for this as well. And lastly, if you find yourself that the changes that you want to introduce in Solidus or the behavior that you want to enhance Solidus with, it's really hard to get into the model or the class that you're decorating. Think about using the event system, as that may provide a better way out. I want to leave you with some resources. I've got all these examples up on a Solidus Events examples repo on GitHub, but look at the guides. I think that's a great way to get familiar with the event system. And if you're curious at what's coming in the newer versions of Solidus and in Master right now, I encourage you to take a look at the Edge guides. They have some great tips and also improvements on the testing. And maybe that will encourage you to upgrade to a recent version of Solidus. Thank you all.